You might think that breakthroughs start with big new questions, but often breakthroughs start with, how does that work that way?
The entire process of what we do on a daily basis just surrounds inventing new questions. I answer one question and I have 5 or 6 or 10 or 20 new questions that I immediately start thinking about. When the center and Don Thomas and his colleagues were first starting, the questions that needed to be answered at a very basic level were mostly concerned with how does the immune system work. One of the reasons why Don Thomas and his colleagues succeeded where others did not was just their grasp of what it is that they needed to learn in order to succeed.
There's so much we don't know today, despite all of these decades of discovery. I think the most visionary thing about having a basic sciences department like Fred Hutch is that the more we learn about the basic inner workings of the cell, the more fundamental these discoveries are going to be.
The type of research that was done in the earliest days of the Hutch and the Basic Sciences Division sort of laid the groundwork for the type of work that now is carried out to this very day.
Practically every cancer treatment that is in the clinic today was rooted in a basic sciences discovery that was made 10 to 20 years ago. These discoveries were not like one-off discoveries. They were built upon decades of painstaking work, often from multiple labs, often rooted in very curiosity-based research.
It's an interesting thing in science that progress is generally so incremental and so hard-won and so slow and difficult and laborious. But at the same time, there can be those extraordinary moments when all of a sudden the pieces fall into place and you arrive at that aha moment of recognizing that something you're working on might be incredibly useful for some much grander purpose.
Immunotherapy, which is so powerful today against cancer, started off with a very basic question of how do immune cells do their communications? How do immune cells interact potentially with malignancies, etc.?
So my lab, for example, has studied proteins involved in gene modification for many years. And that eventually led us to things like collaborating with the Vaccine and Infectious Disease Division, putting molecules that we've studied for decades to carry out antiviral gene therapy against things like HSV and HBV and HIV.
I choose the problem to study because I choose the things that make the least sense to me. That's actually the essence of basic sciences. To go to the edge, realize that the current explanation does not fit, and then figure out what the current explanation is, knowing that that's going to open up entirely new doors of research in many other labs across the world.
We sit right in the middle of an incredibly innovative, intelligent, driven community, and there's a sense of collaboration and learning, exploration and discovery that sort of infuses the entire center on a daily basis.
In fact, we are very deliberate when we hire scientists into our division to hire scientists who are different from us, and that's actually where the true synergies happen. I've been here for nearly half my life, and we work with the same principles that the founders put in place. Be focused, be independent, and be curiosity-driven.